This video is a follow-up to our base example where we published our real-time sensor packets to the public Eclipse MQTT broker. In this example, we'll modify the configuration file we created in the original example to instead publish our packets to a cloud-based Azure Power BI dashboard. Before we begin, it is assumed that you've watched the base example and are familiar with the SoftHub's MQTT capabilities as well as Azure Power BI dashboards. If not, there are links in the video description to direct you to the relevant documentation and videos. We'll start by opening the Rule Engine XML file from our previous example. The only thing we'll need to modify in this file is the Publish Data Action object. To properly configure our Publish Data object, we've referenced the current Microsoft Documentation webpage titled IoT Hub MQTT Support to see what parameters need to be set to successfully connect to our Azure IoT Hub. You can set all of the most common MQTT connection configuration parameters directly via the SoftHub's Publish Data object definition. However, while we won't be using it in this example, we'll point out that you can also set any of the additional MQTT standard configuration parameters, such as last will and testament or alternative security credentials, by using an extended options file if needed. See the SoftHub configuration guide for more information. For this example, we'll need to update the message topic, server username, server password, server client ID, server address, and trusted store file. To save time, we've aggregated most of the information into a simple text file we'll use to illustrate how we build out our Publish Data object definition fields. Again, referencing the online documentation, we will for the most part need to simply substitute our Azure IoT Hub credentials into template strings. This is true for the message topic, where we'll substitute our Azure IoT Hub device ID, the server username, where we'll substitute our Azure IoT Hub name and our Azure IoT Hub device ID, the client ID, where we'll simply supply our Azure IoT Hub device ID, and the server address, where we'll again substitute our Azure IoT Hub name. That leaves two fields we'll need to address, the server password and the trusted store file. Per the Azure documentation, the trusted store file needs to point to the file you've downloaded or created containing the DigiCert Baltimore root certificate. You can download the cert file from multiple places on the internet and use the Azure GitHub link in the video description to verify that the downloaded cert file's contents are correct. Lastly, that brings us to the server password. For the server password, you will need to generate an SAS or Signed Access Signature token. There are multiple ways to generate these tokens. However, we've downloaded the Azure IoT Hub Device Explorer app to build ours. This app provides the additional benefit of being able to test and confirm your SAS token is correct and working before actually trying to use it to connect in the SoftHub. We've previously created our SAS token, so now we'll copy our credentials to the appropriate field on the Publish Data object definition screen. And that's all the changes required to the rule file to redirect our packets from the Eclipse broker to the Azure IoT Hub's MQTT broker. The rest of the rule file remains unchanged. We'll save our file and push it over to our SoftHub device using the PSCP command. Before we restart the SoftHub, we'll take a look at what our generated packets will look like from our previous video. This is an example packet we captured from the Eclipse server, and below that is the Azure Stream Analytics query we'll need to extract the packet data to be displayed on the Power BI dashboard we created. As can be seen, our query extracts three values: the packet timestamp, the temperature value, and the humidity value. These three values in turn will be fed into our Power BI dashboard via our Azure Stream Analytics job. Our Azure Stream Analytics job is already running, so now we'll just restart the SoftHub daemon. Switching over to our Power BI dashboard, we can now see our display widgets begin to update with the real-time data being published from our SoftHub device. Again, this video is meant to just provide the simplest example of how to get your data to your Azure account and Power BI dashboard. Both the OmnIoT SoftHub and the Azure platform provide far more features than we've touched on here. But hopefully we've given you an idea of how easy it is to get your sensor data into your Microsoft Azure account using the OmnIoT SoftHub. Thanks for watching.